The planet is heating up.
The oceans are becoming filled with plastic.
Change starts now. Change starts now.
We're on a countdown
To zero waste. 5, 4, 3, 2, 1.
This is the Zero Waste Countdown Podcast. Here's your host, Laura Nash.
Hi, everyone, and welcome to the Zero Waste Countdown podcast and radio show. On this week's episode, we are speaking with Sangwon Suh. He's a professor at the Bren School of Environmental Science and Management, University of California in Santa Barbara. He has a PhD in environmental science and engineering from Leiden University in the Netherlands, and he also got his master's and bachelor's in environmental engineering at Aeju University in South Korea. His research focuses on the sustainability of human nature complexity through understanding materials and energy exchanges between them. He was appointed as a member of the International Resource Panel by the United Nations Environmental Program and served as the coordinating lead author of the Assessment Report 5 by the Intergovernmental Panel on Climate Change. I really just want to learn about you because I think you've done some absolutely amazing work in the environment that's really going to help us move forward. So I'm interested in learning more about you and then your project. Now, the one study that I was reading about was from Nature, and that is the one that says we're basically on this trajectory to plastic accounting for about 13% of global greenhouse gas emissions. Is that right?
Let me see. So 13% goes 8 gigatons. I'm just dividing things by. It could be 13%, but this is difficult to guess because we don't know what will be the future greenhouse gas emissions, and there were several numbers that were in the in our paper and also some of the news articles. So let me just clarify a few things. So basically, the current greenhouse gas emissions from plastics is 1.88 gigatons of CO2 equivalent greenhouse gas emissions per year. And globally, we are generating about 50 gigatons. So that makes about 3.6% of greenhouse gas emissions associated with the plastics. Okay? And then that can grow to up to 8 gigaton per year. And if we are keeping our current emissions at 50%, that means 16% of the total greenhouse gas emissions globally will be associated with the plastics production and disposal, end-of-life management. Our global greenhouse gas emissions will not be remained at the 50 gigaton per year. It may go up, it may go down. So that's one number. And another number is about the carbon budget. So, let me just kind of clear your questions first, and then I can talk more about the carbon budget calculation.
Awesome. Okay. Well, let's go back and start at the beginning then. So what piqued your interest in the environment?
I kind of started quite early. So when I was in junior high school, there was a TV show, documentary TV show, which was about collecting dead birds around the riverbanks and open fields, and try to understand why those birds died. Mm-hmm. And the study, the documentary found that those birds died out of what is called bioaccumulation, which is that, the toxic substances accumulate across the trophic levels in the food chain. And the birds were, top predators in the food chain. They have disproportionately larger amount of toxins accumulate in their body, and they concluded that that's the main cause of death. And that was very shocking to me. Mm-hmm. As a boy, and I decided, I want to really work on this environmental issues. I want to save the world, and I thought that environmental engineering is the discipline that can do that, which was not. Environmental engineering, by and large, is about really designing the technologies that is cost effective so that it can pass the regulation. And that was not really about saving the world, and I wanted to do, the type of, scientific research that has more kind of holistic view of why these problems occur and what are the relationship between the modern society and the environment. So that led me to the study on industrial ecology.
Mm-hmm. And then recently you have the study that came out in Nature on plastic and climate change. And what got you interested in specifically the plastics issue?
Right. So plastic is one of the things that really characterize modern lifestyle. And have you seen the movie, what is that, The Graduation?
No.
Dustin Hoffman. It's a fun movie. It's a very old movie. I think it was like released in 1970s or even 60s. And in the movie, one of the fun part of the movie is that already at that time, the word plastics at that time the word plastic was very new. And in the movie, an elder man is telling the fresh graduates from a university, which is Dustin Hoffman, said, "Well, you remember just one word. That's plastics." And he believed that the plastics will change the world. And if you want to earn a lot of money, then you have to do something about plastics. And that was absolutely correct. Mm-hmm. Plastics were not mass-produced before 1960s. And since 1960s, the amount of plastics that we generate is really going up crazy. And 1950, the amount of plastics produced globally was only about 2 million tons, but now we are producing about 380 million tons.
Oh no!
And in no way it is possible that much of new anthropogenic flow of materials does not affect the environment. It will affect the environment one way or another. If you are producing that much of material anthropogenically, it will affect the environment one way or another. And we are already, of course, seeing those effects. And many of the, research, scientific research has found the impact on the marine ecosystem. And the ecosystem health issues, and some study found that microplastics are in the sea salt and everywhere that we breathe or eat and touch, and even the ice cores in the Arctic and Antarctica, there are plastics there, although nobody barely comes there. So we know this kind of these impacts that plastics are generating, but interestingly, very few studies ever really looked into the greenhouse gas emissions implications of plastics. Mm-hmm. I think one of the reasons might be that, greenhouse gas emissions are not visible, but, plastics in the guts of penguin, that penguin is really visible. So it's also striking and shocking, and that really led people to got really angry about the plastics in the ocean. But, greenhouse gas emissions, unfortunately, is not visible, although it is really imminent problem that we are facing.
Yeah, absolutely.
So, that got me the interest.
Good. Well, thank you. I kind of wonder why more people aren't looking at this as a problem, because you can just look at your recycling bin,
Exactly.
If you're in North America or Europe, and see how much you produce every week. And if you're not able to get rid of it, it's a lot. And then when you travel, you just see that it's absolutely everywhere. And for me, that's why I started this podcast, because I think it's scary, and I'm not a scientist, and I'm not nearly as smart as you are. So this is my way of trying to get this information out to people, because it's so important, and it's so cheap and convenient and light, right? So it's really good packaging for food, and for different things. So my question is always, how do we change our behavior so that we're taking away our food in a reusable container, or our coffees, or just everything? It's this behavioral change. It is a economical change. There are so many different aspects to it. And, and these studies help so much, because when I read the statistics from your study, I thought, oh my gosh, this is key, because climate change is such a big thing right now, but I feel like not enough people are talking about the plastic part. So when you estimate that, by 2050, we could be up to like 13% of greenhouse gas emissions by plastic, I think that stuff really resonates with people, and hopefully that's a tipping point where people stop using plastic. I'm hoping, or at least, reduce it. It's almost impossible to stop using it.
I hope that's the case. But I think that, probably we will talk more about this, what kind of interventions or measures to be taken to really reduce this impact. But I think that individual behavioral change, studies have shown that in the past is very, very slow and difficult procedure. And I think that there should be a systematic interventions by the government and leaders of the world that really recognizes this and really make dramatic changes. Otherwise, if we rely on goodwill by average people, it would be very difficult to really see a measurable change on the use of plastics. But we can talk more about that toward a later stage of our conversation.
Yeah, I know what you mean. I try to live zero waste, and then for my kid's birthday, I bought him a bunch of berries in those plastic containers.
Yeah.
Luckily, we can recycle them here. But I remember thinking in the checkout, like, what if somebody sees me and I have these plastic containers? Like, it's totally against who I am. It's bad for the environment. And then I realized that everybody else is buying the plastic containers, so nobody is going to judge me because they're all doing it too. And I thought, this is a big problem, and I'm not going to solve it just by my behavior.
Exactly. I mean, let's just face it. I mean, plastics are amazing material. It's cheap, and it doesn't really cost anything, and it's water impermeable. There are very few things that we can find at that price that is not permeable with water. So you can contain things that you want to protect the materials from rain and water. There is no cheaper material that you can buy than plastics. And plastics can be morphed into any form. You can blow mold it, you can cast that, you can cut them. You can really make almost any shape that you want. And it can also be made to the type of properties that you want. Like if you want a rough texture, then you can do that. Smooth texture, glossy, and you can all do that. And also the density can be modulated, color can be modulated. It's amazing, amazing material. So I think that it's wrong to blame really people who need inexpensive material that they need for the purposes that they have. It is really the system that really need to incorporate the external cost, the environmental damages those materials will cause into the price of those materials properly. So that by the time when we are making those purchasing decisions, we don't really have to think about or appeal to the ethics and knowledge on the environment. Basically, the pricing system itself can take care of the purchase of the materials that are more environmentally benign.
Mm-hmm. What do you think about reusables if there were more reusable containers or a rule that...
Absolutely. That's definitely better for the environment. And when you think about reusables, however, as a consumer, I have always a choice. So let's say, if I want to buy utensils, I can buy stainless utensils, or I can buy plastic utensils. Yeah. And if I buy plastic utensils, and then, I can just use it and discard it, and people may feel that it's more convenient, and that you don't have to carry that heavy stainless utensils, and you don't have to wash them either, and it's cheaper. So there are always kind of cons and pros, and by the fact that people are using a lot of disposable plastic utensils, it means that they see more benefit, more utility out of those plastic utensils, especially if you're going for like picnics and having like a birthday party of your kids, as you mentioned. It's so convenient. Mm-hmm. So obviously we can say that, well, instead of using disposable, why don't you use more reusable? It does not have to be stainless, but they can be reusable plastics. Yes, that's possible, but people are doing their own math based on the convenience factor, price, all that. But the current economic system that we are living in, is designed in such a way that disposable ones are preferred because they are so cheap.
I sometimes wonder that our quick way of living, especially in North America, fuels that as well, because a lot of the food that we can get in big cities, nobody wants to wash dishes, and so they'll just give you plastic forks, and it's almost like nobody has time to just sit down for 20 minutes and eat. They want to get their food and go and, eat in people eat in their cars.
Exactly, yeah. I mean, I don't also blame, those people. I mean, they may be busy, and the extra 20 minutes to wash, dishes may mean a lot of things for them.
Right.
There are many reasons. I mean, it is also not about, in some cases, especially low-income families, who earns money hour by hour, those 20 minutes can mean a lot of things for them. So it is unfair to blame them. Oh, yeah, you don't want to wash your dishes, and you are polluting by using the disposable plastics. I mean, there could be many reasons why they prefer, and some of them, I think we cannot really blindly blame them.
That's good. I think so too. That's why I try and focus on positive things and positive businesses, because it's a worldwide planetary problem, and I think we're all in it and we're all part of it. So I agree. I don't like to point fingers at certain groups, and especially lower income families, because it is cheaper to go and buy laundry detergent in a tiny little single-use package, let's say, because I know this happens in a lot of developing countries, than it is to get in a big SUV and drive to Costco or another big box store and get, those big giant things that are like $50 of laundry detergent. Like that's kind of better for the environment. They often come in paper, but a lot of people around the world can't afford that and don't have that option. And so they use the single-use packages or smaller ones, and then that's more garbage, right? So
exactly,
that is a problem for sure. So you mentioned a lot about the plastics and the carbon intensive life cycle. So obviously we're using oil and gas to make it, and it's not very good for the environment. So why is plastic contributing to carbon pollution?
Right. So the reason why plastics are contributing to greenhouse gas emissions is because in order for the factories to produce plastics, it has to go through a whole bunch of processes. First, crude oil needs to be extracted. As you mentioned, plastics are predominantly produced out of crude petroleum as feedstock. As I will tell you more about different types of feedstocks, it is possible to produce plastics out of trees, out of plants, out of corn and sugarcane, but predominantly currently we are producing plastics predominantly from crude petroleum. So extracting crude petroleum itself is generating greenhouse gas emissions because there are a little bit of methane in the oil wells, and you either flare them or transport them, and there are many reasons why they may be leaky and generating greenhouse gas emissions. And then, once it is transported to refinery, then they will try to separate water and separate gasoline, diesel, jet fuels, and what is left is naphtha. So those distillation processes is also energy consuming, and it generates greenhouse gas emissions. And once it's distilled, then it will be cracked, or it will go through many different types of chemical processes to generate what is called resin. So resins are the basic building blocks that can be transformed into various different types of plastics. And all those processes, step by step, requires energy, transportation, and generate greenhouse gas emissions there.
Wow. So that's just before it even gets to a place where they make it into plastic. Like this is just to make the resin, right?
Exactly.
Wow. Yeah.
And then, once the resin is made, then, if you want to extrude it or blow mold it, you have to heat it. And heating process also requires energy and generate greenhouse gas emissions. And so that's conversion, what is called in our paper. And then once it is sold to the consumer and being used, very little greenhouse gas emissions, if any, are generated during the use phase. But once it's discarded, it can be incinerated. Then, all the carbon molecules in the plastics will be converted into CO2. And that's greenhouse gas. And if it is composted, so some of the bio-based plastics are compostable, and if it is composted, again, it will generate CO2 emissions. So mainly, if I just summarize, the main reason why plastics life cycle generate greenhouse gas emissions is because the extraction, production, and conversion of plastics will generate greenhouse gas emissions, as well as the end-of-life management of plastics, including incineration and compost, will generate greenhouse gas emissions.
So if regular plastic is being broken down in a compost, it would basically turn into like microplastics, right?
Right. Well, if it is fully composted, the idea is to break down those molecules into smaller molecules. It can be microplastics, or it can be fully biodegraded, so that very little plastics left, if any, and all of them are converted into CO2.
So 100% petroleum-based plastic can go away through compost? Because my understanding was that it can't go away. Okay.
So the compostable plastics are made out of biomass feedstock.
Corn.
Currently, corn, exactly. Corn and sugarcane. Those are the two main ingredients, main feedstock that is converted into biodegradable plastics.
When that composts, so if we use the biodegradable plastics, will that produce methane as it's being composted?
It can be methane, it can be CO, carbon monoxide, or it can be carbon dioxide.
And if those compostable plastics end up getting into landfill, if someone just throws it in the trash, would that produce methane eventually?
In the long run, some of them will be converted into methane, but we know very little about the fate of the plastics in the landfill. So we have actually reviewed some of the studies that are out there that talks about the biodegradability of plastics in different environments, and there is very little evidence of how fast they degrade in the landfill environment, if any of them is degraded.
Have you heard of Tom Zaki from TerraCycle? He wrote a book, and he's an entrepreneur, and they did a study in landfill where they just dug up some bags, and they found a head of lettuce and a half-eaten hot dog and a newspaper dating from 50 years ago. So, but he started the Loop program too. I don't know if it's like a mail order thing for food, and when you're done with your container, you just throw it back in the box. And
I see. I didn't know about that one, but I think I've heard about him.
Yeah, he sounds really cool. So yeah, by correlation, basically they've dated that a head of lettuce will not decompose in a landfill after 50 years.
That's crazy.
And that the newspaper won't even go away at all, so you can still read the date. The newspaper was still readable. So that really scares me, honestly.
Yeah.
That's really disturbing.
But that's also an interesting issue in connection to greenhouse gas emissions, because, we want, some of us feel that, well, if plastics are all easily decomposable, then we will not have problems of ocean plastics, right? Part of us believe that, plastics should be made easily decomposable so that we don't really see them in the environment. But there will be a disaster for climate change.
Because you have to grow all those crops to make the plastic?
Well, because if they are decomposed, what they are decomposed into?
Methane.
They are decomposed into methane, or more likely CO2.
Mm-hmm.
So because of the sheer volume of plastics that we are generating, converting all of the plastics into CO2 means a massive amount of additional greenhouse gas emissions to be generated. So for the greenhouse gas emissions point of view, so climate mitigation point of view, the best solution is actually to landfill them and prevent them to be decomposed and generate CO2 emissions out of it.
Oh, no.
But of course, there is a trade-off, because we don't want this valuable resources sitting in the landfill not decomposed for millions of years. No, that's also, not good. So what I'm saying is that, I'm not necessarily, advocating, landfilling all the plastics, but, we have to understand that there are trade-offs. There is no single solution that can satisfy all the ecological, economic needs that we have, and we need to really understand the trade-off situation that we are in.
Yeah. Yeah, and landfills have the problems too, because methane will be piped out and groundwater can be contaminated.
Yeah.
From them too, and then they get crowded, and there's an island, what is it called, the Cayman Islands, and the highest point on the entire island is the landfill. It's like a trash mountain.
Yeah.
and it's leaking into the coral reefs and stuff. So that's a problem. But I should ask you, because you might know the answer to this. So I've read that CO2 is measured in a 100-year lifespan. And so when you compare methane to CO2, methane seems less bad for the atmosphere because it basically is quicker, like the damage is quicker and only goes about 30 years. And then it kind of is like gone from the atmosphere. So people typically seem to focus on CO2 as a big problem. But in the short term, in those 30 years, I've heard methane is worse. Do you know?
Yeah. So the methane has a much higher capacity to absorb heat and re-radiate the infrared as heat back to the Earth. So it has much higher potency of warming the globe. However, you're absolutely right that their lifetime is short. Mm-hmm. So how long methane lives, it's difficult to tell because they kind of go asymptotically to zero. So they will not completely disappear until like hundreds of years. So we normally measure half-life. What mm-hmm. is the time that methane, at half of the methane that are just created will disappear. Okay, so half-life-wise, methane is really short. I don't have those numbers top of my head, but I can easily find them. And CO2 is very stable, so it stays in the atmosphere for a very long time, hundreds of years. Still you will see, significant portion of the CO2 emitted will reside in the atmosphere. So you're absolutely right that if we really measure greenhouse gas emissions in terms of their global warming potential, what is called, within a shorter time horizon, let's say 5 years, then methane has a lot higher potency as compared to CO2. But if we expand the time horizon within which we measure the potency of these gases on global warming potential, then, methane becomes relatively less potent as compared to CO2 because most of them will be gone.
Yeah. Okay, that all makes sense. And did you happen to read the National Geographic article? Maybe it came from a science study that you would have read about when plastic breaks down just sitting there in the grass or wherever, that it releases CO2 as well?
Oh, yeah, it does. I think I read that, and there was a researcher who studied that. So that's very interesting. So, what we found was that, plastics in the ocean takes really long time to degrade, but plastics in the terrestrial environment, especially when they are exposed to the sun, they can be degraded relatively quickly. Mm-hmm. The question is, how much of plastics that are generated to the environment will sit on the ground exposed to the sun? And I think that this is a relatively smaller portion. But still, you're absolutely right that will contribute to the emissions of greenhouse gas emissions. However, if you compare those amounts coming from the discarded plastics exposed to the sun as compared to the amount of greenhouse gas emissions emitted due to the large amount of energy consumption throughout the life cycle of plastics and also disposable plastics, the former is relatively small.
Yeah. And are there certain types of plastics that would emit more gases than others?
Yes. So polyester, polyamide, and acrylic is, in terms of the greenhouse gas emissions intensity, is the highest. So they are generally used for garments.
Yeah, polyamide is used, I think, for fish nets too. Mm-hmm. And they're like a big problem in the ocean. Mm-hmm. Yeah. So let's talk about your 4 strategies, because this is something that a lot of news outlets focused on from your article. So what are your 4 strategies for reducing the carbon footprint of plastic?
Those 4 strategies include 1, use of low carbon energy, including renewable electricity, mm-hmm. instead of current mix of energy. 2nd, recycling of plastics. 3rd, reducing the growth rate of consumption.
Yeah.
And replacing petroleum-based plastics by biomass-based plastics. Those are the 4 strategies. And those 4 strategies can be combined together because they are not mutually exclusive.
Yeah, I don't think any well, I mean, if we reduced our use for it and didn't use single-use plastics, I suppose that would solve it. But I just don't see that happening because, as you were saying before, they're just so helpful and convenient for people.
Exactly. And also the important thing to notice here is that the plastics are produced in a way as an attempt to utilize what was wasted. So basically the naphtha, which is the main feedstock for making all kind of different plastics, is a byproduct or waste. It was a waste product out of petroleum refining to produce gasoline and diesel. So after extracting gasoline and diesel, you get kind of thick, black, dirty-looking materials out of the refinery, and people, basically discarded them, just landfill them or dumped to the ocean in the past.
Oh my goodness.
Because we didn't know how to use them. It was only 1950s and 1960s and 70s people understood how to make use of those materials that have been discarded and started to produce all kind of different plastic material out of that. So what I mean by this is that, as long as we are using gasoline and diesel, there will be the amount of plastic feedstock for plastics will be produced. Okay? So even if we completely stop using plastics, still we will have the materials to be produced out of the gasoline and diesel refinery, and if we don't do anything, we will just discard it to landfill.
Wow. So it's basically like the same thing. Or would that be more detrimental to the environment to be putting that naphtha in a landfill or the ocean than it is to put plastic in the ocean or landfill?
Well, I think that if we put all of them into ocean, it will be much more detrimental because plastics are more stable as compared to naphtha, and naphtha is more toxic than plastic. So in a way, what we are doing with plastics is better than throwing the naphtha away directly.
Okay, so does that fall into your first solution, or is that more for reducing fossil fuels in the factory of making plastic, basically?
Yeah. So we found that the most kind of most significant or substantial reduction in greenhouse gas emissions from our scenario analysis was actually transitioning our energy system into low carbon energy system, and the reducing our growth rate of the plastics consumption from 4% a year to 2% a year. So those two are the most profound. So those two have the most profound effect in reducing greenhouse gas emissions from plastics life cycle.
Mm-hmm. Yeah. So if we all stop driving and using gas and oil and stuff, then that would help, I guess.
Oh yeah, absolutely, yeah.
Oh, it's a very fascinating thought, really. And so the other thing is bioplastics. Now, I know that some states, I think California specifically, was struggling a little bit to separate the bioplastics from regular plastics, and then they weren't really sure what to do with them. So how are bioplastics better than petroleum plastics?
Yeah. So bioplastics currently are not really composted. So the original idea of bioplastic was that, they are biodegradable, so we can use bioplastics without worrying about, plastics in the ocean. But the reality is that bioplastics don't degrade in the ocean environment. It is as inert as petroleum-based plastics.
Really?
In the ocean environment, yes.
Ah, that's so disappointing.
We have another study that we are finalizing, which is about biodegradability of different types of plastics under different environment. And the big myth about bioplastics is that their biodegradability. So they are biodegradable only under a very specific condition, and that condition is maintained only in the industrial scale composting operations. So if you just discard it to the environment, basically they are as inert as petroleum-based plastics.
Wow. Yeah, that's really disappointing. I just assumed that if they got into the ocean that they would break down and...
Exactly, yeah. It will behave more or less the same as the petroleum-based plastics. So the reason why bio-based plastics are better in terms of greenhouse gas emissions is because the origin of the carbon molecules in bio-based plastics are from the atmosphere. So currently the largest feedstock for making bio-based plastics are corn and sugarcane.
Mm-hmm.
And those carbon molecules in corn and sugarcane are coming from the atmosphere. So through the photosynthesis, those carbon dioxide in the atmosphere were converted into organic materials, and that's what we are using to produce, PLAs and other bio-based plastics materials. And that is completely different, fundamentally different from petroleum-based plastics, because petroleum-based plastics were already, safely stored under the earth crust in the form of crude petroleum, and we are extracting it, and burn it, and liberate to the atmosphere. So that is a net addition to carbon stock in the atmosphere, whereas the carbon molecules in bio-based plastics were originally from the environment, so we are not necessarily adding to the environment. But the reason why it does still generate greenhouse gas emissions is because, as I said, the processing of the materials and transporting them and those kind of things all generate greenhouse gas emissions. Even for bio-based plastics.
But also the disposal, right? Because when...
Yeah, exactly.
Yeah. So does growing bioplastics take out more carbon from the air than it puts back in the air when it's composted?
No. So the bioplastics do have net addition to greenhouse gas emissions to the environment. So if you think about just the carbon in the plastics, carbon molecules in the bio-based plastics, they will be equal, right? The amount of carbon that they absorb from the atmosphere will be equal to the amount of carbon that they will be liberated to the atmosphere when they are decomposed in the form of compost or incineration at the end of their life. But then, if you just count the molecules in the material, it is net zero emission. But the problem is that you need to use energy to process them and heat them, distill them. All those chemical processes will generate greenhouse gas emissions, and that's why it has a net addition to greenhouse gas emissions. Now, if you put all those bio-based plastics at the end of their life into landfill, so that you prevent generating greenhouse gas emissions at the end of their lives, let me see whether it will reduce greenhouse gas emissions overall or not. So we do have those numbers. So they will be the same as 100% recycling. No, but it will still generate a little bit of more greenhouse gas emissions. So even if we put those plastics back in the earth crust in the form of like landfill, still the amount of greenhouse gas emissions generated throughout the processing of the bio-based plastics will be higher than the net reduction in greenhouse gas emissions due to the photosynthesis.
Yeah, and those extra emissions are things I would assume like the tractor, that is taking care of growing the corn. I'm sure there are fossil fuel based fertilizers and
exactly.
Like pesticides, and then the heating for the compost facility, the trucks that would have to like transport all of these things. So all of that.
Exactly.
Cost.
But if you completely decarbonize all of them, so let's suppose that we are using renewable electricity, and those vehicles like tractors are battery powered electric vehicles, and the processing of the corn and sugarcane and converting them into different types of chemicals and converting them into plastics, all those things are powered by renewable electricity. Then if you put those bio-based plastics after use into landfill, so that you don't generate any greenhouse gas emissions out of it, then there will be net negative emissions, meaning that this will work as a carbon sequestration.
Wow.
But there's a lot of if, as you may have noticed.
So much work, right? It just makes so much more sense to just like not take that plastic cup from the store, just grab some water when you get home. That's my theory. But as you said before, it doesn't work for everyone. So we have to find things that work in our society. So, I mean, that is a good vision.
I mean, the general statistics is that globally, the amount of plastics that are recycled is less than 10%. It's a 9.85%.
Yeah.
So over 91% of the plastics that are produced are not being recycled. So they will be discarded one way or another.
So for me and my listeners, as a scientist, Could you give us a little explanation of how scientists determine these statistics?
Well, there are generally two ways in which you approach this kind of a problem. One is top-down approach, which is that we look at the global production volume for plastics and the production of the recycled plastics, and then you kind of deduct how much could have been recycled to meet the amount of the recycled plastics that are being generated. So using kind of global statistics at a very high level and try to deduct that. Another way is to assemble country by country kind of data on recycling rates and their volume, and try to assemble them together to come up with a global statistics. So one of the reasons statistics actually were done by my colleague, Roland Geyer, so he basically tried to reconcile those top-down versus bottom-up estimations and came up with a number.
Yeah, it seems like it would be hard to do, but I guess if you are a recycling facility being paid for by tax money, you would have to keep statistics. Like you would have to be weighing the trucks and the bales and keeping track of all that information. So
exactly.
Yeah.
And one of the people that I work with is from Unilever, and they set their vision to eliminate petroleum-based plastics by, I think it was like 2030 or something like that.
Really?
The things that they need, scientific information on what is the best for them. So they didn't know about, whether bio-based plastics are better or worse, and what does it really mean to have them. So all those things, I think, is important for us to have this kind of, scientific measures on the environmental impact of these different alternatives before they take action. So many of them are really genuinely interested in understanding better.
Good. Yeah. Like what if you take $1 billion and change your company and then do something that's just as bad for the environment as you were doing?
Exactly.
So you kind of painted a nice picture for us with the carbon-free tractors and fossil fuel-free kind of way of living and growing these corn-based and sugar-based plastics. Do you have a vision sort of for the world of how we can live sustainably going forward where we don't meet these really bad greenhouse gas emissions from plastic?
What we concluded in our paper was that the decarbonization of energy is really the priority, which sounded a little odd because we talked more about plastics, which is really tangible material. Then now the solution is really decarbonizing energy. So people may think that there's a disconnect. This here is on one hand we have this material, and on the other hand the decarbonization of energy, which is fairly different thing from plastics, but they are not different thing because anything that we do use energy, and energy use is the primary source of greenhouse gas emissions in most cases for any materials and product that they were consuming. So decarbonization of energy, it will provide multiple benefits, not only for plastics, but it will also green other industry. And before we think about any other things like, shifting into bio-based plastics or, improving recycling rates and all those things, of course, it will benefit the environment and reduce greenhouse gas emissions. But first and foremost, we want to decarbonize our energy systems. We found that that's really important. And then once we do that, then we can explore other options that we have listed in our paper, including, better recycling. 10% bar is so low. We can easily improve that. We can double, triple, quadruple it. We should be able to. And some countries are already doing it. So countries like China, believe it or not, their recycling rate is much higher, so over 90%.
Wow.
So there are ways in which we can achieve much better recycling rate than what we have today. And that requires not only the behavioral change, but also systematic changes by the leaders and the polity of the world by, for example, incorporating external cost environmental damages into the pricing of plastics more properly, for example, so that we don't have to rely on individual goodwill and the system takes care of those behavioral elements in our society. So those multiple dimensions of actions, I think, should be able to bring down the greenhouse gas emissions by plastics. And if we can do that, we can do that for other materials and other goods and services as well.
Yeah, absolutely. Do you have any specific example of how to increase recycling rates? Because I think that garbage should be taken away in clear bags, but we had someone come on the show and say, no, that would just cause fights between, people who live in their house and the garbage man. That sort of thing wouldn't work. Do you have any specific things you've thought about to increase recycling?
So we are actually working on improving the recycling layer of plastics. There are multiple dimensions of actions that can be taken, and much of that requires quite serious research and development and new technologies too. So one very simple way, it sounds simple, but of course implementing it requires a lot of effort, is to just simply increase the price of plastics, which sound odd, but it will really improve recycling rate. The reason why recycling is not done in the United States is because virgin material is cheaper than recycled materials. Mm-hmm. So you put a lot of effort to collect recyclates, convert them and clean them and convert them and generate a little bit of recycled plastics after all the losses that take place. And then, when you try to sell it, virgin plastics half of the price that what you are generated. So why would you do recycling? It doesn't make any economic sense. Yeah. So if the virgin plastics are priced much higher, then recycled plastics will still have economic competitiveness. Currently, we don't. So that's the primary reason why recycling is not happening. And obviously, we can talk about separate collection and better management of contaminants, all that. But all those things will be taken care of if there is a higher value of recyclates and recycled materials. So that's one thing. Another thing is that there are a number of technological solutions that have not been implemented partly because of the fact that, the recycling doesn't really generate profit. So, for example, you may notice that, when you look at the plastic bottle, the body part of the bottle has a different, so the cap is a different material than body part of the bottle.
Yeah.
So, when we are doing recycling, actually, we actually have to separate them. But separating them manually takes a lot of effort, right? So what normally happens is that you basically chop them into small pieces, and you normally grab it to separate them. So there can be air separation, like you imagine that there's a conveyor belt, those chopped plastics particles are going through the conveyor belt, and then they are dumped into the air, and then there is a fan blowing underneath, and then lighter ones go farther and heavier ones fall down.
Cool.
That's one of the separation methods. But those separation methods have very low efficiency. So there will be always contaminants, and those contaminants degrade the quality of recyclates, and that is one of the obstacles of recycling. But those obstacles can easily be addressed by modulating the density of different materials. So some countries actually mandate manufacturers to produce those caps and the body of the bottle with certain threshold density difference. So if densities of those two materials are large enough, then the contamination rate goes down dramatically. And so there's another technological solutions, and another kind of policy solution in Japan is that, in Japan, by law, all the bottle manufacturers are required to produce their labels that can be ripped away by one go. Mm-hmm. So those labels are, again, a different material, and they are contaminants in recycling, so they should be easily removable. But in the U.S., removing those labels are a nightmare. But in Japan, it can be very easily removed so that you can maintain the quality recyclates. And besides, there's a whole bunch of new chemistry that are being developed to improve the recycling rate. So we generally try to create monomers out of the polymers. Polymers is basically what we call plastics, and the efficiency is very low, but there are new a form of chemicals that have very high efficiency conversion between the polymers to monomers. So in these cases, those monomers are bonded with materials that can be easily dissolved under certain solvents. So once you put those, end-of-life plastics into solvent, basically it dissolves those bonding materials so that it generate monomers with very high purity. But those are not yet commercially available, but there are a lot of research being done.
So what would you do? What would you do with those monomers?
Well, then monomers can be easily converted into polymers again, so that you can recycle them with almost 100% efficiency. Currently, the efficiency of recycling is very low, so you lose a lot of materials because of contaminants. But in this case, you can maintain almost a near 100% efficiency.
That's almost like aluminum, where you can melt it down and then just reform it, right? And I think that's the myth about recycling. I think that's what a lot of people think plastic recycling is they're taking plastic, they're like melting it down and making it like brand new again. But
no. We're losing up to 20% while doing that. So in many cases, more than 20%, depending on the quality of recyclate. So it's a very inefficient process.
But if we took the polymers down to monomers and then put them to polymers again, we would have nearly 100% recovery.
Yeah, these new breed of chemicals, new breed of polymers are able to do that, but these are more expensive, and there is no commercial plant that are actually producing them.
That would fit in well with your recommendation to make plastics a bit more expensive. Would a plastics tax work as well?
Well, I think that it can be. It can be. There are two things that I want to mention. One, I think it will be arbitrary to say plastics tax, because some people may say, well, why don't we do paper tax, or why don't we do this tax or that tax? But instead, if we can, for example, institute carbon tax, carbon pricing, which is probably more universally measurable than other types of environmental externalities, it could be a significant improvement already. So it does not have to be plastic specific. If we tax carbon, that could do it. And another thing that I want to mention is that when we talk about increasing prices of materials, I know that whoever say that will not be very popular. Nobody likes a higher price.
No,
and think about what happened in France, Yellow Vest. The riots and violent demonstrations happened only for about 30 cents per gallon of gasoline tax increase. It was just proposal. And so if we talk about the substantial increase in the material price for plastics, it will easily backfire. There will be social resistance against it. And partly because plastics are so valuable and cheap, especially for low-income families. We need to find ways in which we can protect the low-income families if we decide to increase the price of plastics.
Yeah. So we just put a carbon tax in Canada federally, and it hurts lower income families because they can't afford to get a brand new EV. So they are driving in their gas guzzlers and they're paying more. And then in Canada, it gets down to minus 30 Celsius here. And so we don't have any other way to heat our home without oil and gas. So I feel like our carbon tax here is really hurting those people, whereas people who are rich they wouldn't care about their hot tub or their 6-bedroom home or whatever, right? So it's tough for that. So I hope that in Canada, we can focus on things to get us away from the two things we depend on to survive here, which is transportation to work and then also heating our home. So things like geothermal, like if there's more use for that, then we wouldn't have to use propane and stuff to heat our homes. So we have different challenges up here for sure. But I'm glad you think about everyone, because it really sucks to see people who are struggling. It sucks to see the government implement things that make them struggle so much more. Like I don't like to see that. So
yeah, agree.
Yeah. So do you do things in your own life to reduce your waste?
Well, I think about it all the time, and not always successful. But,
Me too.
yeah. One of the things that I practice is dietary intervention. So I try to eat less meat and more vegetables, and it's also good for health. And so there are good co-benefits with that. So that's one of the things I try, and I want to try to live a simple life as much as I can.
Nice. Yeah, we had a show it's from the Millennial Minimalists, and it's all about just kind of living with less clutter in every aspect. Yeah, and it's nice. It's a little bit liberating. You have less stuff to clean, less stuff around your house to tidy up when you just buy less. So it's nice. Yeah.
Exactly.
Yeah, well, this has just been really informative. I've learned so much. I feel like my head is spinning a little bit because there are so many things I didn't know. So thank you very much for taking the time and speaking with me today. And I will try to watch and see if you come out with any more studies, because I'd love to bring you back on and talk about anything else that you end up finding for us.
Great. But it was a pleasure talking to you.
Thank you so much, and have a good day and keep up the good work.
You too. Bye.
Take care. Bye. That was Sangwon Suh from the Bren School of Environmental Science and Management at the University of California in Santa Barbara. If you like our show and want to help save the world from all this trash we're consuming, please consider donating to the Zero Waste Countdown. You can become a patron on Podbean, you can find me on Patreon, or you can donate right on the website, zerowastecountdown.com. And if you're interested in seeing a photo of our guests, you can check us out on Instagram. That's _waste_countdown. And if you want to email me, it's laura@zerowastecountdown.com. Thank you for listening, everybody. Thanks to all our listeners in America, Canada, Australia, Germany, the UK, and wherever else you may be tuning in from. Together, we're going to change the world.
Change starts now.
This is the Zero Waste Countdown Podcast.